MIT professor Francisco Stolacci and Rice University's Vicky Colvin are two scientists who think of the world in really, really small terms. And in two very different ways, they're each trying to use nanoscale technology to help clean up the world's water. Stolacci's revolutionary nano-wire matting has the look and feel of paper, but it could be a powerful new tool for cleaning up oil spills.
It's ideal in absorbing oils in a situation where there is a lot of water around, like the ocean.
Professor Stolacci's so-called nano-wire paper can absorb 20 times its weight in oil. Its development was inspired by a biological phenomenon known as the lotus leaf effect.
A lotus leaf that are on the surface of lakes. Yet, even though they are very close to water, they're always dry. Their surface has nanostructure so that it traps a lot of air, and air is a substance that repels water.
Nanowire paper replicates the structure of the lotus leaf.
What we've generated is a material that is made of manganese oxide nanowires. They are like human hair, they're long but thin.
Stolacci's nanowire material is completely impervious to water.
We took our paper and put it in water and left it there for a week, and when you take it out, it's still dry. But if there is any oil around, it will absorb it, and it will do so very efficiently. Cleaning the ocean from environmental disaster, we could be purifying storm waters and allowing a lot of places in the world to have better drinkable water. What excites you is the fact that through your work, you can be impacting the life of many.
Rice University professor Vicky Colvin is also searching for new ways to clean up water. She's taking on the nasty element arsenic.
Arsenic's one of those substances I think everybody sort of knows is a bad thing. If you eat a lot of arsenic all at once, you can get very sick right away. You can also get sick if you have a little bit of arsenic over a long period of time, particularly in your water. And arsenic isn't introduced into water by people. It's actually a naturally occurring substance that's usually bound up in soils that have a lot of irons.
While areas of the United States have more arsenic than we might like, places like Southeast Asia and Central and South America are the hardest hit. In Bangladesh and West Bengal, India, more than 50 million people have suffered chronic exposure to arsenic from naturally contaminated water.
You really end up with some very severe consequences as a result of arsenic poisoning.
Colvin says the solution could be a tiny particle called nano-rust.
Well, nano-rust is basically rust, but it's nano-size. Our materials are about 30 to 10 nanometers, which means they contain thousands to millions of iron and oxygen atoms inside of them.
Which means large amounts of arsenic can be absorbed by small amounts of nano-rust. Also, nano-rust can be produced locally in a low-tech, affordable way.
If you take olive oil that you buy at the grocery store and you add some lye, you let it sit, it makes a soap. You heat up that soap, you add in some rust, you heat it up to the right temperature, you make nano-rust. Kind of amazing.
It's the oleic acid in fats such as olive oil that breaks the rust down into the smaller nano-rust particles that bond with the arsenic. Colvin had solved a major problem, but another large hurdle remained.
So even though you do have this ideal sponge for arsenic, it's still in your water, and we would put it in these enormous centrifuges and we'd pull out our particles, but that's not going to happen in the plains of West Bengal.
The surprisingly simple solution was literally close at hand: a handheld magnet.
Those little tiny particles, which don't have a lot of volume, have a lot more magnetic punch per atom. What that means is very small magnetic fields can pull them out of solution.
Professor Colvin hopes field tests in Guanajuato, Mexico will show if her tiny breakthrough can work on a large scale. In the meantime, she and Professor Stolacci will keep thinking really, really small.